Guys, it's Miss Leslie and I'm coming to you with a video about perfect squares and perfect cubes. I think that the name of this lesson is talking about squares and cubes and how we're supposed to estimate large quantities and find volume and area for 2 and 3-dimensional figures. Okay, so guys, as always, I always like to start off by telling you what each one of these things mean. So let's start with perfect squares. This is my definition of what a perfect square is. A perfect square is a number or its opposite that has been multiplied by itself that's underneath the radical. For example, guys, the square root of 4 is 2. And not only is it positive 2, but it is also negative 2. And the reason that it is both positive 2 and negative 2 is because if I were to take 2 and multiply it times itself, 2 times 2 is positive 4. And another way, you guys, that you know that you can write 2 being multiplied times itself is to use your exponent, is to use your power. 2 to the second power, or 2 squared, is also equal to 4. And because negative 2 times negative 2 is also positive 4. You guys know this from your integer op rules. A negative times a negative is a positive, and 2 times 2 is 4. Another way that this can be written is that I've got the entire quantity, negative 2, being raised to the second power, which is showing that negative 2 is being multiplied by negative 2, which also gives you positive 4. Guys, it's a good idea for you to memorize all the perfect squares, at least 1 through 13. Those are the ones that I suggest that you learn for 8th grade next year, and I also suggest that you learn a couple more. So I want to run through all the perfect squares 1 through 100 real quick to make sure that we know all of these, because they're going to come in good handy for you now and for later. So 1 squared under the radical would still be 1. That means that the square root of 1 is also 1. The next perfect square would be 2 squared, which would be 4. And remember, guys, that both of these answers would be both positive and negative. What is 3 squared underneath the radical? 9. 4 squared would be square root of 16. 5 squared would be the square root of 25. 6 would be 36. 7, 49. 8, 64. 9, 81. 10, 100. 11 times 11 is 121 under the radical. 12 times 12 is 144. And 13 times 13 is 169. Guys, those are the ones that are most popular. And if I can be honest, guys, I also suggest that you make sure that you keep in the back of your mind what the square root, the perfect square for 20 is, and that is 400. And the perfect square for 25, which is 625. Those always come up as well. So guys, these are all the perfect squares, or the rational numbers that use the radical. You guys talked about irrational numbers last week, numbers that are not these perfect squares that also have a radical on them, and we know that irrational numbers fall between these two perfect squares. For example, the square root of 2, there's no number that you can multiply times itself to get 2, but I know that it should fall between the square root of 1 and the square root of 4 because those are perfect. Alright, so guys, another root that you'll see is a cube root. Guys, remember that a cube root is a number that has been multiplied times itself 3 times that is underneath the radical. Notice, guys, I left out the opposite because cube roots are not always its opposite. Cube roots will depend on what is underneath the radical. Alright? Here's an example, guys, of us finding the cube root of a number. Now, guys, you can tell that cube roots are different because instead of just having the radical symbol, you have a little 3 in the corner that tells you that I'm looking for the root of negative 8 that has been multiplied times itself 3 times. So the only number that I know that I can multiply times itself 3 times and get negative 8 under the radical is negative 2. And the reason I know that is because negative 2 times negative 2 times negative 2 is negative 8. A negative times a negative is a positive, and a positive times a negative is a negative. 2 times 2 is 4, and 4 times 2 is 8. Guys, remember that you're multiplying, not adding, okay? Another way that we could write negative 2 to the third power is the negative 2 in the parentheses to show that both the negative and the 2 are being raised to the third power or being cubed. So negative 2 cubed equals negative 8, okay? So guys, there are only a handful of perfect cubes that I suggest that you memorize, and they are the cube roots of 1 through 4. Okay, so what you need to do is multiply real quick and figure out what these perfect cubes are. 1 times 1 times 1 is 1, so the cube root of 1 is 1. Then you've got the cube root of 2 times 2 times 2, which is 8. That's the one we just did up there. 3 times 3 times 3 is 27. So the cube root of 27 is 3. I also, guys, suggest that you learn the next perfect square, which will equal 4, and that is 64, because 4 times 4 is 16, and 16 times 4 is 64 underneath the radical. Guys, the last thing that they ask you to do is they're asking you to use what you know about perfect squares and perfect cubes to find area and sometimes volume. The reason that they're using area is because what you guys need to make sure that you remember is if you have a square, and I know, guys, this doesn't really look like a square, but I wasn't really thinking about this when I was writing this morning. So let's pretend that this is a square. I'll even label it square, so we'll know it's a square. But when you're multiplying, when you're trying to find the area of a square, what you're supposed to do is multiply the length and the width together, or sometimes you guys call this the base and the height. And the good thing that we know about a square is that all sides are equal. So what I'm saying is, if this square is 2 units this way and 2 units this way, what you're really doing is taking your measurement for area, which is length times width, or area, which is base times height, and because both measurements are the same, you're taking them and squaring them. So it's like saying 2 squared, which is going to give you 4 units. Okay? So guys, essentially what area is your measurements squared. Guys, the same thing for volume, especially of a cube, because we know that a cube has, because it's got depth, we have 3 units of measurement that we're supposed to use. We have length, width, and height. But the thing about a cube that we have to remember is that instead of 2 measurements, we have 3. So when you have the volume of a cube, what you're actually doing is finding the length times the width times the height. Well, if all the measurements are the same, it's really like saying 3 cubed, which we know now is 27 units. Okay, so guys, please make sure that you're keeping that in mind. So I'm gonna write down these measurements for you real quick. It says find the length of the side. So if this side is 5 units, and I'm asking you to find what the other side is so that we can find the area, all you have to do is say that it is 5 squared to give you 25 units squared for the area. Same thing for the measurement of the cube. If you're trying to find the length of a side, you need the measurement of one side. I'm going to make this one side 4. And remember to find the volume of a cube. It is length times width times height. So what I'm really saying is what is 4 cubed. And we now know that that is 64 units cubed. Okay, so guys, that's just a little short introduction to how we use squares and cubes the correct way, because you're dealing with bigger units of measurement. I'm hoping that this will clear this up for some of you, and if you have any questions, please make sure that you inbox me. Thanks, guys.